Okay, so perhaps we should just start with a very short intro. We are also waiting Roy on our end to join us. And while it happens, let me just tell you that we are thrilled to have this webinar to discuss some of the challenges with hosted Iceberg. As many of you know, Apache Iceberg has emerged as leading open source table format. But in spite of that, managing Iceberg has not always been as straightforward as it seems. So today, at the moment, Yingjun, who founder and CEO of Rising Wave Labs, and Alex Merced, Senior Tech Evangelist of Dremio, will get to discuss some of these challenges. We're still hoping Roy will join us very soon. And yeah, he will introduce himself when that happens. So perhaps Yingjun, you can start.
Sure. Yeah, we can. Yeah, let's just. I mean, look. I prefer for everyone here is to discuss with the iceberg thing, right? Well, but just give me 1 minute to do a self intro. Oh, 30 seconds, okay? And I'm a founder of Rising Wave. Rising Wave is if you don't know Rising Wave, what Rising Wave is, just check our website. Basically, stream processing, real-time ingestion, all these kind of things, right? And that's it. Okay, I just want to leave it short. And hey, Roy. Okay. Yeah.
Hey, John, how are you?
Yeah, pretty good. So actually, it's your turn to do a self intro. Okay.
Sure. Do you want to go now?
Sure. Yeah.
All right. Awesome. So are we actually recording or?
Yeah, we're recording. Yeah.
Oh,
so...
awesome. This is great. Sorry for screwing it up. So my name is Roy Hassan. I was the VP of product at Absolver, recently acquired by Click. Now I head the product team focused on storage and data lake or lakehouse management capabilities inside of Click.
Cool. Alex, your turn.
Hey, everybody. My name is Alex Merced. I'm a senior tech evangelist at Dremio, where I specialize specifically on really kind of educating and enabling people on the lakehouse, creating content around Iceberg, Apache Arrow, Apache Polaris, Nessie, all sorts of really cool lakehouse technologies. So hopefully you've probably come across one of my blogs or books, and there's a lot more to come. I'll leave it at that.
Yeah, cool. You probably can share a link about your book, right?
Yeah.
All right, yeah, let's just have some discussion about Iceberg. So I actually also talked to some of our customers when they always ask me about, okay, why I need to move to Iceberg. Before diving deep into this topic, could you please, you two, could you please give a talk, give a pitch about why to choose Iceberg? Look, because there are so many options, right? Well, we can use Snowflake, I probably can use Redshift, right? I came from Redshift.
Yep.
I used to work in Redshift. And probably we can use some Postgres. Well, Postgres is definitely very popular. So why Iceberg?
Okay. Basically, the way I would look at it is first, the question is why you should choose Lakehouse. And bottom line is when you think of coming from technologies like many data warehouses, what often happens in very large enterprises is you have different business units using different data warehouses. So you find yourselves ETLing the same data into one data warehouse after another data warehouse in every business unit. The benefit of the Lakehouse is that you can have data warehouse-like tables on your data lake that regardless of whether you're using Redshift, Snowflake, Dremio, or any other tool, you can run analytics on the same data without having to replicate it over and over again. And in that, Iceberg specifically really has some of the best sort of community adoption, one of the largest ecosystems of tools and support for it. So if you want to go for that sort of interoperable, single source of truth data, Iceberg is going to really offer you the biggest reach across your tooling to enable all your different teams to use the tools that they want on a single copy of the data for maximum consistency.
Yeah, and I think Alex touched on a lot of good points. Just to kind of add to that, I think from a business perspective, right, there's sort of two main aspects. The first one is openness, right? So the whole idea of the Lakehouse and using open file formats and open table formats allows you to sort of extract your data out of the grasp or the hold of the traditional warehouses, Snowflake, et cetera, inside of proprietary formats, and take that out. So now you have a lot more flexibility and portability to be able to move your data between solutions across clouds, right? Kind of like what Oracle locked us into in the past and cost you millions of dollars to get out of. With Iceberg, for example, in open formats, it makes moving from one tool to the other much, much simpler and cost effective. The other aspect of it regarding to cost is you're now in control of how you're going to use this data. So when you put it all into a warehouse like Snowflake or Redshift, you got to use their compute to perform transformations and queries. But if those engines aren't best suited for a certain type of use case, like transformation, data cleanup, those kind of things, or are too expensive for that, you don't have the option to use a different tool because you're locked into that platform. So by taking that data out and putting it in open formats, now you have more control to say, I want to use Absolver, for example, or ClickNow to do the transformation and ingestion on the data, and I want to query the data with Dremio, and then I want to query it with Snowflake. Right? With these open formats being outside of the warehouse, you have that capability. Previously, if it was in the warehouse, you got to use Snowflake for everything, and then you pay the bill, right? So that's for me, it's kind of the big differences: openness and control over how you implement your solution. You control your cost at the end of the day.
Yeah, but why, a follow-up question, why not just use Parquet format? Because I know that we can just store Parquet format, we can just store data in Parquet format and just put them in S3. And then I can use my Athena query engine, right, from AWS to query the data, probably use some, I don't know, DuckDB to query Parquet file, right? Why not just a Parquet file? Why I have to use for Iceberg? Is Iceberg an alternative to Parquet file or what?
Well, I mean, Iceberg works over Parquet. So the Parquet is still going to be the best way to store the actual like raw data for analytical purposes. The problem is Parquet files only have metadata about the data inside the file. So so if I may have a data set that's 1,000 or 100,000 Parquet files, and each of those individual files have no awareness of the other. So, basically what ends up happening is that a query engine has to read each file. And while they can use the Parquet metadata to kind of avoid reading parts of the file, they still have to open up the file. So you're still having a lot more IO operations happening. Now with Iceberg, what it does, it takes all the metadata from the Parquet files that make up the data set and rolls them up into groups of files, into partition level stats. So that way a query engine can actually say, hey, I don't need to scan this whole chunk of Parquet files. And then really end up saying, hey, out of this 100,000 Parquet files, for my particular query, I only need to scan 5. Which really reduces the IO operations necessary to complete a query, resulting in a much faster query. But this also enables another thing, ACID transactions, which you're not going to have with Parquet if you're just treating it as a pure Parquet data set, in the sense of being able to know that, hey, did this transaction succeed or fail, and make sure that if a transaction fails, it doesn't affect future reads of the table and things like that. That metadata layer really provides the ability to treat those tables more like a data warehouse table.
Roy, do you have something?
Yeah, I mean, Alex is great at that. That's what he does every single day. So he explained it really well. I think maybe a little bit more adding to that is, the difference between obviously Iceberg and Parquet is like, yes, you can do all the things that you just said with Parquet. The main difference, as Alex kind of alluded to in the beginning, is the metadata, right? And how do you interact with those tables and able to deliver the same functionality that you would expect from a warehouse on top of, a bunch of files in S3, where in the Parquet world, you have to implement those things, right? You got to write the code in Spark or in whatever to do the compaction, to do the merging of data. If you have a bunch of, upserts or deletes, you have to do a lot of those things. And granted, you can do it, and people have been doing it in Hive for a while, but it's a lot of extra work. It's a lot of extra code. It's fragile. It's just not easy to do at scale. Where Iceberg does is it sort of standardizes the way that those operations happen and provides you with a spec, right? So everybody can adhere to that spec, but also provides a set of SDKs that if you wanted to bring this into a Java application or a Go application or a Rust application, you can easily take those SDKs and use it. So it sort of levels the playing field across the different tools, not just the big players like the Sparks and the Flinks and the Trinos, like really levels the playing field to say if anybody wants to interact with this data in the lake, Iceberg gives you a map, right? Gives you a set of SDKs that make it super, super simple. So you don't need to be a Hadoop vendor or know anything about big data in order to start using it. And I think that's the really powerful piece about it.
Yeah, that's super cool answer. And basically, one sentence to summarize is that Parquet is the open file format, while Iceberg is the open table format. And the table can consist of probably hundreds or thousands or even tens of thousands of files, right? Well, open Parquet files, right? So these are two different things, and yeah, at the two different layers. So if you have already had a Parquet, you don't need to do anything. I mean, you can just layer on top of Parquet file, right? Well, I don't know how easy it could be, but we can talk here later. But well, essentially, Iceberg is a layer on top of Parquet. You don't need to change anything. You don't need to migrate data. You don't need to do that. So just add a layer, just add a Iceberg layer on top of that. Cool. So in the second question, who should adopt Iceberg? Like startups, enterprises, Snowflake users, Databricks users, or what? Yeah.
I mean, Iceberg, I mean, you could adopt Iceberg generally at any point, but honestly, like if your data set can fit inside of a single Parquet file, you may or may not really need Iceberg at that point. Because one of the big benefits of Iceberg is the ability to say, hey, I have a lot of Parquet files, but for one individual query, I only need to scan a portion of them. Now, even if you had one Parquet file in your data set, you still get benefits with Iceberg, such as like time travel, whatnot. But really, at the end of the day, Iceberg is really built for large data sets that you really kind of generally going to have in one place. You're going to have one copy of that data set on your object storage, but you're having different tools, different departments working on that data. Generally, as your use case gets smaller, smaller use cases, you're probably going to find other tools probably more convenient. Yeah, more convenient in those early stages until you really get to that point where you do have a bunch of different departments and business units working with the data in different ways and different tools. So that would be sort of my take on it.
Yeah, I agree with what Alex said, but I think I want people to think about it in a slightly different way, right? So what Alex said makes a lot of sense, right? You're starting small, just do something small, like you don't need to start implementing Iceberg, blah, blah, blah. But as you're doing this, you need to think about where you're going, right? Are you going to be at this level in a year from now, meaning that you're going to be playing around with files on your computer? Or are you going to have to take this stuff into production with large tables, with other users, and security and all that kind of stuff? Ultimately, my perspective is Iceberg just works with a lot of the native tools that you do today. Why not just start with Iceberg? If you're in Python, just use Python, use PyIceberg and just work with it, right? If you're using DuckDB, use Iceberg as well. Hopefully they'll add catalog support soon. But you can do that, right? If you're ingesting data or transforming data with Python and then querying with Dremio, just use Iceberg. Why would you go and start playing around with CSVs and Parquets and then later switch to Iceberg? Just start with Iceberg if that ultimately is where you want to be, because it's already integrated. And the SDKs that are out there that you can plug it into a lot of things, just start using it. It's like saying, do I start with CSV or do I start with JSON? Does it really matter? Like ultimately, if you're going to be doing a lot of stuff that works with CSVs, then start using CSVs. But if you're building applications and use JSONs everywhere and you like the JSON protocol, just use it from day one, right? It just works. It just works in a lot of systems. So my point of view is look into the future. Where are you going to be? You don't want to be migrating to something else later. So start today with Iceberg. You don't need to know anything about it. It just plugs into your existing tools and it works just like as you would writing a Parquet file, you write into an Iceberg table.
Yeah, that's definitely a great question, a great answer. Look, well, I talked to a bunch of guys and they told me that, well, look, well, I don't really have a petabyte of data, right? But what I'm thinking is that, well, look, well, it's not about where you are now at the moment. Well, it's more about what you want to be, right? Well, where you want to go, right? And first thing is that whether your data will be growing bigger, right, and bigger, right? So let's say that you are currently using Redshift. Again, I used to work in Redshift, and I still host AWS stock, okay? And but I have to say that, so, like, if you use Redshift, the thing here is that I mean, your data is starting Redshift. But if you want to think about, well, I mean, if I want to query my data using DuckDB or probably using some other tools like Python, like Java, it's really hard for me to do that because I actually have to copy the data out from Redshift, right? But if you put the data inside of Iceberg, then there's no vendor lock-in, and there's you actually have the open access to the data. You can use for, let's say, Redshift, DB, Gmail,
It's
Snowflake,
agility, right?
yeah,
You have agility, right?
yeah,
And
that's right,
I think that's
it's
the
open.
bottom line. It's not about having small data or big data. It's about being agile and being able to sort of continue with your work as you grow and you add more capabilities. And you may never get out of like 100 gig, right? You may still be doing 100 gig, but you're going to have 20 users inside your organization. You're going to have users demanding, Power BI, and other users demanding something else. Like, how do you support them? You're not going to support them with a Parquet file sitting on your laptop, right? So I think it's really important to kind of think about, it's not just about big data. It's about agility and flexibility as you grow and be able to kind of do that. Because you said, right, why would I put my stuff into Snowflake or Redshift? I'm a small company. I don't have the money. I don't have the ability to do it. I write it into Iceberg. I use, let's say, Amazon Athena to query it, or even DuckDB. And then 6 months from now, we get a little bit more money. We can afford Snowflake. We get a CIO that really likes Snowflake. We buy Snowflake, and I can keep going. I don't have to do anything different. It just works, right? So agility and flexibility, I think, is the biggest benefit in my mind. And sorry to cut you off there, Eugene.
Cool. That's definitely a great answer. And let's move to the next question. How to remove this? All drawings, and I heard that in Iceberg we actually have to manage catalogs, right, for metadata, and essentially you can also consider Iceberg itself as a catalog service, right? For I kind of like, Iceberg is a format, but it definitely needs to have a catalog service so that you can you know where the query is, right? Where the data is, right? But I find that there are so many catalogs, and I have no idea about why there are so many catalogs and which one I should pick.
Well,
that is a good thing.
Yeah, no, it's a very good thing. And I mean, where it comes from is just that, like, in the early days, basically sort of the evolution of the catalog space is like, first you had everything kind of written in the Java API for Iceberg. So basically the way you created another catalog was through sort of a Java interface. And basically all the catalog needed to do was to track, say, hey, here's the name of a table, here's the location of its metadata. So you had different catalog implementations, because in those early stages, you're like, okay, how about we use a database as a catalog? So you had JDBC catalog. Well, what if we want to use a file system as a catalog for like unit testing? So there was a Hadoop catalog. Then there was, other catalogs created for different vendors. So like AWS created like a Glue catalog and a DynamoDB catalog, which since has been deprecated. And then basically a dedicated catalog solution. So one of the first ones was Nessie came out. So they had to come up with their own interface, which was a catalog sort of more dedicated to Iceberg. But then other people started creating more dedicated Iceberg options. And then you had Tabular, who came out with a commercial offering. So you had all these sort of different people saying, hey, what they think a catalog should be. And you want that competition, because basically this has pushed the boundaries of what a catalog is and allowed people to innovate and put out different ideas. The problem that happened is with so many different catalogs and everything sort of being based off, a class in a particular language, is that as Iceberg expanded into Python, to Go, and to Rust, this theoretically would require every catalog to re-implement itself in every language. And then for every managed solution to adopt all those additional classes into their platform, which would be kind of daunting. So you had this sort of period of sort of fragmented support for catalogs, but that sense has been fixed, because now you have a uniform interface for catalogs called the REST catalog interface. And now most catalogs have now adopted this interface. So if you're talking about Nessie supports REST catalog, Apache Polaris supports REST catalog, Apache Gravitino supports REST catalog, Unity catalog supports REST catalog. So they all support one interface. So nowadays you can have lots of different catalog options and a lot of different managed catalog options that offer you more than just cataloging your tables, but also different types of governance features, different types of management features to give you a more data warehouse-like experience with your Iceberg tables. But you don't have, basically you have that sort of uniform support across all your tooling, and you can have this ecosystem of catalogs. So that way, again, you don't have vendor lock-in, even at the catalog level or at the table level. Basically, the idea is you're just open at every level.
Mm-hmm. Yeah. So a follow-up question, I know that definitely Roy has his answer, but a follow-up question is that you mentioned that all these catalogs will have the REST catalog interface, right? So the follow-up question is that so can I just pick one catalog, one type of catalog, let's say Polaris, and then let's say switch to some other catalog for all kinds of reasons, like okay, my CTO really loves this catalog, and can I just switch?
Yeah, pretty easily. Out of the Nessie project, actually, Ajanta Bhatt, who's a big contributor to Iceberg, he created a catalog migration tool. So it's like a CLI tool where you just put in the credentials for one catalog and the credentials for the next catalog, and it'll move all the references over to the new target catalog, making it pretty easy to shift over. So yeah, pretty easy nowadays.
Yeah, and just to add to that, I think the beauty of the Iceberg REST catalog specification is that it first of all, it standardizes the language, right? The way that engines talk to this catalog. And the second piece of it is it decouples the implementation from the old school Java-based, Hadoop-based type of catalogs, like with the Hive catalog, right? And that made it so much easier for other companies to just go build a catalog. Nobody wanted to touch, the Hive space because there's so many dependencies and it's so heavyweight that like who wants to build another Hive catalog? But with this REST specification, it's a web service, right? And that's why you see, obviously Nessie, you see Lakekeeper, you see Data Hub, you see Polaris, like they're all coming out there and saying like, hey, I got this, this Iceberg REST front end, but in my back end, I'm going to start giving you a whole lot of new cool stuff that you didn't have before. Like Nessie got this awesome, versioning and kind of GitHub like experience. Lakekeeper got an amazing access control pattern that I think is going to change a lot of things in the way that we do governance. And then Data Hub got a lot of really, really cool stuff with regards to data discovery and access controls and operational metrics around data quality. So like all of a sudden we just blew up this catalog space, and we said we no longer need to just be a data catalog or some simple technical catalog. We're merging them together. And I think the Iceberg REST spec enabled that. Now, which one do you choose? It shouldn't really be about which one works with your engine. They all work with your engine. Is which one is going to address your business needs? Do you need RBAC and access controls? Fantastic. Do you need a lot of versioning and other stuff? Well, what are your options, right? So now you got flexibility, you got options, and I think that's the really powerful thing about the catalog space inside of the Iceberg ecosystem.
Yeah, so I'm not an expert in, there's a question, I'm not an expert in Hudi and Delta, but the question is that why does Iceberg require catalog while Hudi and Delta can function without one? Any reason for that design?
There's a couple benefits. Now, again, part of it is the way that Iceberg is designed. So basically, when you take a look at Hudi and Delta Lake, Hudi uses a timeline. So basically, like every transaction has literally a timestamp that's associated with it. So then you can kind of derive sort of the order of the transactions. Two, in Delta Lake, you have like these JSON logs. So it's like log 1, log 2, log 3. So knowing what the order of the transactions are to reconstruct the table is pretty straightforward, but you still have to reconstruct the table. You start from the first transaction and then you apply each incremental change like GitHub. Iceberg takes a different approach. Instead of sort of saying, hey, let's start from the beginning and rebuild the table, let's have unique separate definitions of the table so that you don't have to go back and rebuild. So basically what happens is that Iceberg has completely isolated snapshots. And at the top of the Iceberg metadata tree, you have a metadata.json that lists all these different snapshots. But every time the table is updated, a new metadata.json is created. So in that case, the engine needs to know, hey, which is the correct metadata.json that's going to have the most up-to-date listing of snapshots for this table. And that's what the catalog does. It says, hey, the sales table, here is the file location of that most up-to-date metadata.json. Now, which again allows it where you don't have to do this historical rebuilding of each table. Instead, you just have a listing of saying, hey, these groups of files are the table that have, that are completely isolated from every other previous version of the table. And this basically makes certain patterns possible, like partition evolution, where sort of each snapshot can have its sort of where its own unique sort of partitioning scheme or its own relationship to a partitioning scheme. But at the end of the day, you still want a catalog, because even if you're using Hoodie or Delta Lake, you're eventually going to want a catalog, because catalogs are also going to be the center of where you're doing governance and other things. So like this is what's happening now a lot with like Unity catalog, with Polaris catalog, where, you know, even though people can use Delta without Unity catalog, they want to use it with Unity catalog because they can govern the tables there. They can say, hey, this is the central place that knows, hey, these are the tables that exist and who can access them. And, you know, for Hoodie, you would probably use something like an AWS Glue right now, or a Hive. The options are a little bit more limited there. But basically, you're starting to see this catalog thing become important in those other table formats too, because people care about governance and they need somewhere to define that governance. Because if you're using different engines, the engine can't be where the governance is. It has to be somewhere that's all the engines talk to, which would be the catalog, versus, you know, just going directly to the file system, which may not be able to contain the same information to be able to govern the access.
Yeah, I actually Roy, go ahead. Yeah.
Yeah, sorry. No, I was just going to add a little bit. I think generally speaking, all the formats can work without a catalog, right? Iceberg can work without a catalog. You simply point to the latest manifest and you do it. The difference is that Hoodie has a hints file that tells it which one is the first manifest to work with, and Delta just uses one long log, so you always point to the same place. So they're a little bit easier to find the entry point into that table, where Iceberg kind of expects you to know what the entry point is, but you can use all of them without a catalog. Like Alex said, that's just very short-sighted. Sorry, Alex, you didn't say that. I said that. But the idea that Alex was talking about is, this is just very short-sighted. That the argument that, well, these other formats can work without a catalog, but Iceberg can't, that's just really only applicable for like local development. Like when I'm sitting on my laptop and I'm, you know, I don't want to stand up a catalog. I just want to point to this table and I want to read it. It's a convenience thing. But in reality, it's completely irrelevant, because everybody's gonna have a catalog. If you're putting this data into production of any sort, users need to write into it, they need to query it, you need to update it, you're gonna use a catalog, right? You just have to. That's how you access data from multiple engines. That's how you do discovery. That's how you do access controls. So to say that, you know, Iceberg is not good because it doesn't have a non-catalog option is just short-sighted. It's not really understanding how you put this stuff into production. And honestly, I've heard that comment come from a lot of people who just kind of do local development and don't really do much in production. Because the second they go into production, like, yeah, we need a catalog. So again, I don't know if I'd put too much emphasis on that, on this particular item.
Yeah, there's actually one more question for Alex, but let me summarize first. Well, catalog is for governance. Let's say that we have a lot of query engines, okay, Snowflake, Redshift, or whatever, right, DuckDB or whatever, right, and you want to access the data. But the problem here is that for every single, let's say that I believe that we probably do not really work alone, right? We probably have your teammates, so probably have different departments, and different departments actually have access to different data, right? Where you probably do not really want to share the data with everyone, right? Then you actually need to have the RBAC, role-based access control. And you probably don't really want to configure such kind of role-based access control in every single engine, right? I know that's very possible, but to think about it, what if you got a new colleague, right? Do you want to change the catalog in every single database? Probably no, right? So you actually need to have a centralized place to set up this permission, right? That's why we have the catalog. And
Yeah,
definitely it's
right.
more than just let's say the permission. It's more about, also talk about, Alex also talk about let's say the versioning, right? Yeah, you probably want to figure out, okay, which, if a new version is created, what will happen, right? It actually essentially a governance tool. And regarding RBAC, where there's a specific question, so Alex, probably you can just give a pretty short answer. And the catalog offering from Gmail that can offer RBAC for table and column levels access. Any suggestion?
Oh, okay, so let me just create a quick line between RBAC, role-based access control, versus FGAC, fine-grained access control. Because which one can be handled by a catalog versus which one can be handled by an engine, there's a distinction. Because role-based access control is just saying, okay, hey, this person with this role or this particular user can access the table. So that can exist at the catalog level. because in that point, you don't have to read the data. You just have to say, okay, hey, this particular credentials are trying to access this table. According to my rules, they don't have access to this table, so we're going to reject that request. So a catalog can handle RBAC pretty easily. Now, FGAC, fine-grained access control, is still probably going to have to be the foray of the engine, because that requires you to read the data first and apply whatever rules, saying, hey, if the value is this in the column, hide that column or something like that. The actual application of FGAC requires generally that the data has already been read. So that's going to be more on the level of the engine. So even with like an engine like Dremio, where you do have an integrated Iceberg catalog that has RBAC, so you can apply RBAC that you can then bring over to, connect it to Spark, connect it to Trino, connect it to Snowflake, and those rules will carry over. The FGAC portion would then still be engine specific. So then Dremio would have to run those queries to apply the FGAC, and then other engines would have to have their own FGAC rules applied, just because of the nature of how FGAC works.
Okay, so basically you say that Dremio can handle the column level access, right?
Dremio can do column and row level access, but that's going to be at the engine level, not the catalog level. While Dremio can handle RBAC at the catalog level, and a lot of these catalogs that are coming are starting to handle more and more of that kind of RBAC style security at the catalog level, because the catalog can know, hey, these credentials are coming in, they're requesting this object, reject or don't reject.
Okay, and do we still need to use Apache Rancher? I mean, it's a kind of like old technology, right, for Rancher? Probably no, right?
Not if you're using something like an Apache Polaris, which is one of the technologies that's powering, let's say, like Dremio catalog, Snowflake's open catalog. You wouldn't need that, because you can define those rules within Apache Polaris. Apache Polaris has a pretty robust RBAC system. Now, let's say you're still using Hive catalog for your Iceberg catalog, and you still have and you already have an existing Apache Ranger deployment. You can use Apache Ranger with tools that support it, like Dremio does support observing those Apache Ranger rules. But ideally, you would want something that's going to be able to work with nowadays, a lot of this, with the REST catalog specification being there, you can create something that's going to be more adoptable across a much wider ecosystem without every engine having to adopt. Like, for example, to enjoy Polaris's RBAC rules, the engine doesn't have to do anything. All it does is connect to the catalog, send the request to the catalog, and all that happens behind the scenes. While every tool would have to build out like Apache Ranger support. So you have, you're starting to see less and less of that as newer tools come out. So in that case, you'd want to kind of move to that newer paradigm.
Cool.
Just to add to that, and I can't talk to what Dremio is doing, Alex did that, but I think one concept to kind of talk about, and we've done this when I worked for AWS on lake formation, this is something that we kind of wrestled with, is when you talk about fine-grained access control, right, row level type of access control, is where do you put the trust, right? Do you say, I trust the engine to do the right thing? Because like Alex explained, the engine has to read the data first, all of it, and then it then applies the policy that says, okay, don't include these particular rows in the result set that I'm going to send to the user. So you have to trust that the engine is going to do the right thing, and that the user is not potentially, hacking it or jailbreaking the engine to extract the raw data out of it. And that's something that we struggled with. And when we built lake formation, is that we said, we want to own the data because we don't trust the engine will do the right thing. And that worked okay, but as you got to scale, like, it started to break down, because you're basically filtering all the data through you in order to extract the stuff that shouldn't be returned to the user. And then from a scale and performance perspective, it was a massive degradation. So I think the Iceberg REST spec and sort of the Iceberg catalog model is sort of changing that, and is saying, you know what, I do trust the engines. I do trust Dremio to do the right thing. I do trust Snowflake to do the right thing. So in the future, we will have fine-grained access controls inside of the REST catalog, but it does depend on the engine to actually do the right thing. And then it becomes much more flexible for other engines to come in and do it. So you don't depend on Ranger that does a whole bunch of hackery and trickery inside of each of the engines to ensure that nobody messes with it and it returns only the right data. So you don't need custom clients in each of the clients, and so in each of the engines that you're using.
Yeah, that's
but it's an interesting area. I think we're going to see a lot more development and innovation around this in probably the next couple of years.
Yeah, I think probably we can spend another hour to discuss this.
Yes.
Well, yeah, I know. I mean, like for the
You should have Christian from the Laykeeper team to come and deep dive into that. I think he has
Oh
some
yeah,
good
definitely, yeah,
ideas on
definitely.
that.
There are so many catalogs. Well, like, well, we probably can find the time to discuss all these kind of catalogs, right? So,
Yes.
like, well, how many catalogs are there? There are probably 10. I don't know, or even more.
Right.
Like,
Yeah,
the ecosystem is
we've
quite
had
big.
one for 20 years, so now to have 10, it's actually a good thing.
Okay, yeah. And so actually, there's another question, but well, I don't really want to spend too much time on this. Well, that is for, I mean, attribute based or access control, right? Well, and so basically, RBAC is role based,
Mhm.
right? Access control.
Well, yeah. So
There's another thing called ABAC. ABAC is like ABAC. It's
Mhm.
attribute.
There's also
Yes.
T-back if you want to go that far.
Yeah.
There's lots of backs.
Okay.
Yeah.
It's all the same thing. It just translates different policies.
Just I spent 1 minute, okay,
Oh,
to discuss with this. Okay,
yeah.
just
Well, ABAC or TBAC, I mean, honestly, those probably could be implemented at the catalog level, just because they don't require you to read the data. It's just you could probably store tags and attributes in table metadata, and then just have the catalog refer to that table metadata to determine whether to apply a particular rule or not. I don't think any of the current REST catalog batches have implemented that yet, but I don't see why it wouldn't be in the near future. Or in the next year or so, as people keep advancing those catalogs governance features.
I mean, if you look at Glue catalog with the REST endpoint and lake formation, you do have TBAC, tag based, very similar to ABAC, but yeah.
yeah. So
But again, I mean, it's different ways of defining your policies, right? So rather than defining it on a role, you can define it based on a tag. And if you tag your resources a certain way, then you can apply permissions based on that. And ABAC's the same, right? Attributes. What attributes in your data do you want to, build your policies on? So it's a lot of flexibility, but like Alex said, like it's more complicated to implement those policies on the engines, because like Spark, for example, probably wouldn't know how to implement that kind of policy. So like something the Ranger does in their client is you define an ABAC attribute, right, and it translates that into a different set of policies that Spark can actually implement within their query plan.
yeah. So yeah, I don't really want to confuse people, but I want to mention that REST is there's something called the REST catalog spec, and you can imagine it like a standard. And these are all different implementations. And the Glue catalog is I think Glue catalog is based on Hive, right? Meta is all right, yeah. But Glue
Say it again. Sorry.
it's Glue catalog based on Hive, Hive catalog. Okay,
No, it's not. It's on top. It uses DynamoDB. It basically it exposes Hive compatible set of APIs.
Okay. Yeah, I used to work in Redshift, and I have no idea about what you guys know.
Yeah.
But well, anyway, so yeah, it's based on DynamoDB, and it's a AWS solution. Basically, if you are in AWS, yeah, it's the default solution. But well, it doesn't really mean that's why it offers the best. It's the best option, right? So you probably can explore different options for sure. Okay, and Unity catalog is basically supported by Databricks. Well, Polaris, well, I mean, it's more kind of like more open, right? And because there have a lot of vendors like Dreamview, Snowflake, Riding Wave, and many others. Yeah, definitely a lot of people support Polaris. Yeah. We spent a lot of time on this topic. Well, let's move to the next one. Okay. Okay. But why? Okay, we talk about a catalog, and I also heard that there's another thing called a compaction. Why we need to do compaction, right? So I think probably Roy, you are one of the best person to answer this question. Because I know that in Observer you mentioned a lot about I mean yeah, right. Well, why we want to do compaction and how to make the data smaller, right? So can you give your answer to that? Yeah.
Yeah, I mean, compaction is a common practice for optimizing your data files. So typically it's used to take a bunch of small files and compact them or combine them into larger files that are much more efficient when you query them. So it's kind of like a standard practice across the board. There's standard way of doing it, just take a bunch of small files and merge them into big files based on a target file size that you want. And that's what the Iceberg SDK does fairly well. There's some properties that you can configure to kind of tune it a little bit. But over the years, something that Absolver has been doing for a long time, but we're seeing more and more engines are doing it as well, is just becoming smarter about when to compact, how to compact. Do you sort the data while you're compacting, right? Do you maybe do like Z-order sorting, or do you cluster it in a different way? So now you're kind of adding to the compaction to make it actually much more efficient. So the results of the files that you produce are faster for engines to query, right? Without going into the details of like the small file problem, compaction is really a way to solve that. But it also opens up the opportunity for you to go do more stuff to the data to optimize it.
Yeah, Alex.
Oh, just add a quick bit about that, and just like, so that's 100% like awesome. All right. Just one thing I want to just mention is that the reason why like this is necessary for like Iceberg and Delta and Hoodie, because all three of them have this problem, is just that you've now, when you go to the data lakehouse paradigm, you've moved away from a data warehouse. Data warehouses used to do this stuff for you under the hood because you were in their ecosystem. So they would take care of all this stuff with you. You'd never have to think about it. But the catch was you were locked into their ecosystem. Now, the cost of getting that openness that Iceberg provides is having to think a little bit more about, how do you maintain those tables and track those tables and govern those tables. A lot of these implementation details you didn't have to think about with the data warehouse, but you get the flexibility, the openness, and a lot of the cost savings and consistency benefits when you do embrace the lakehouse. And then, now this is becoming easier. You take a look at what Absolver was doing with a lot of their automated maintenance. Dremio is doing things with automated maintenance. The Apache Players project is actually looking into creating a hook, so that way, as tables change, it can actually broadcast a signal. So that way, other engines can use those signals to trigger these compaction jobs. So, while this was a thing that you had to spend a lot of time thinking about in the early days of Iceberg and the Lakehouse, nowadays, a lot of these companies we're providing services to make this a lot less of something you have to worry as much about.
So, but how to do compaction? I'm kind of confused, right? Well, because we say that okay, we can compact a bunch of smaller files into bigger files. I understand that, but how to do compaction? Will the engine do the compaction, or should I use some tools?
The engine generally does it. Originally, there was some procedures that were built into Spark.
Okay,
and basically,
Spark, yeah.
So basically Spark was your option. Nowadays, more engines have more tools. So like Absolver had their implementation of tools that would do that. Dremio has its own implementation for optimizing and expiring snapshots. And I think there's other engines that might have their own implementations of procedures to do these jobs. But sort of like the default was the procedures that were built into Spark in the open source project.
Yeah. Yeah, in most cases, like if you're using open source tools like Spark and Trino or any of those, like you'd run your job or your SQL operation, and then you'd follow it with an optimization step, right? So like you run a job, you write data to S3, and then you execute optimize, right? To optimize the data and compact it. In tools like like Absolver and Dremio, it's sort of part of the process. So like in Absolver, when we write the data, we ingest it, we write it into Iceberg, we're continuously optimizing it, right? So there's no need for you to run another job or schedule another job for a later time. We're continuously optimizing. And if we see that we're writing a lot of little files, we're going to start compacting them much more aggressively. If we're writing bigger files because the flow of data is slower and there's more data, then maybe we don't need to compact as aggressively. We can actually back off and write the bigger files initially. And that's kind of where a lot of the innovation comes in around compaction and optimizations. But yeah, if you're using something like Athena on Trino, you'd run a job, and then typically you'd schedule some out-of-band task to say, go compact that table, right? So now you have to create a scheduling with like Airflow or something and say every hour run a compaction job on top of this table, or the user have to manually know or in advance know that after I run my query to update a table, I need to also optimize it. So there's sort of like the ad hoc way and the more automated way, kind of what Absolver and Dremio and even Snowflake's doing.
Yeah, I actually have a lot of questions, and also there's another question called, are we supposed to execute a compaction after each change in the table? And the procedure is supposed to be expensive or what? Look,
Yeah.
and also I want to ask, like, okay, I'm not a fan of Spark, okay, because I feel that Spark is kind of like too heavy. And I don't really let's say that's right. If I want to just maintain Iceberg, and you ask me to, okay, look, well, I mean, you have to probably maintain Spark as well. I think probably it's like a two, yeah, right. Well, you can imagine that how expensive it could be, right? So, is there any solution for that?
Yeah, I mean, you have the growing options as we've mentioned, where you have like different companies offering different managed solutions. So you have Upsolver, Dremio, or I guess Upsolver Click now, having these automated options. Snowflake, AWS, I think, has added some stuff with the S3 tables, where a lot of these things will just be taken care of for you behind the scenes, with different algorithms, different ways they do it. But again, with Polaris, as far as figuring out when to do the job, because that is part of the hardest part, like, okay, how often should I do this? Because different tables are going to increase the amount of data they have at different paces, depending on what type of workload it is and whatnot. And then how that data is being ingested can affect how you want to do that. Like, do I want to cluster the data while I'm compacting it? There's a lot of these sort of questions. At least Polaris, on the other hand, with that subscription service, can at least help you identify when these table changes are happening. So that way you could actually set policies saying, hey, compact this table after like every 6 snapshots, and then that signal can then be broadcasted and engines can subscribe to it and then do compaction however they're going to do it. Or you might have some third-party optimization service that does it. There's also different possibilities, but the options are expanding.
Yeah. And Roy, in Observer, did you run EMR or run Spark or what?
Nope, it was our own engine.
Oh, your own engine. So basically,
Yeah.
and so basically, there are some engines that can automatically do the compaction, right?
Yeah, I mean, you can actually take the Iceberg SDK, and that functionality is built into the SDK. You can use it, so you can build your own compactor, right? Your own compaction engine. I've seen people actually launch it using the Java SDK or even using the Pi Iceberg on top of AWS Lambda functions to compact their tables. So I think there was a question about, do you need to execute compaction after each change in the table? Well, it depends on the table, right? If it's like a CDC stream that's bringing in like a lot of data and it's going to be lots of inserts and updates and deletes, then yeah, you'd want to compact because you end up with a lot of little files. But if it's a batch job that you write the data using Spark, let's say, and you predetermine how big your files are going to be, and you're kind of set, then you don't really need compaction at that point because you already kind of defined the size of your files. You're not going to have small files. You're going to have big files. So you're going to be good there. So it really depends. And I think that's the challenge with, orchestrating your own compaction, is that you need to know what these tables are doing and how they're changing and how their data is structured over time, and keep adjusting the way you do compaction, right? So when Alex is talking about the catalog sort of sending notification, that's good to say, hey, the table was changed, 5 files were added, here are the size of each files. Somebody needs to make a decision, now is the right time to compact, or hey, it's not the right time to compact, I'm going to wait until I get 10 more files and then I'm going to compact, right? So there's some intelligence there. It's going to fall on somebody's shoulders, right? Whether it's you manually or some tool like Upsolver or Dremio or whatever. So there is some complexity here, and I think overall, like bringing some of these engines to market that are not part of a query engine, are sort of standalone, allows you to take advantage of all the moving pieces and all the properties available for you, and really control the entire market, so the entire lake house, and make sure that the performance that you get out of these compactions is consistent across whichever engine you're going to query with. Because you don't want to compact with Snowflake and it's going to work great in Snowflake, but it's not going to work well in Dremio, right? You want an engine that can do it all across the board and give you consistent behavior. And it's not that easy to do.
Sorry,
yeah. Long answer.
So yeah. Okay, never mind. Well, and look, well, there are definitely a lot of solutions in the market, and you can definitely use all kinds of the solutions like Dremio, Upsolver, or even to be honest, well, I mean, ReadingWave will probably in the future also offer the compaction service where you can also subscribe and see. And if you are just in AWS and say that, okay, I'm just loyal to AWS, right? Where in AWS it's great, right? Well, and AWS has the S3 table, and we'll probably cover that for later. And even if you use, let's say, EMR, right, we don't really want to use AWS S3 table. You feel that's right, it's probably kind of too new. But you can check the AWS website, and there's documentation telling you how to basically this thing basically tell you how to use your EMR to do the do the compaction for
Yeah,
Iceberg.
it just basically runs a Spark job with the procedures that Alex was talking about, and that's it. And you can do the same thing on your own.
Yeah, it's not.
You can do it in Apache Iceberg and doing all that stuff. But again, it's you knowing when to compact and what properties to pass to the compaction function.
So I have to know when to compact, right? For the machine, I mean, all EMR will never know when I need to do a compaction, right?
Nope, you gotta know.
Yeah, good. Yeah. So actually, there's a follow-up question, and I think I can answer the question because it's kind of like relevant to RatingWave, what RatingWave does. So the question is that can you talk about how Iceberg works with real-time data ingestion, right? So look, think here that's for I mean, you definitely need to have some tools, like upstairs, right? You also mentioned upstairs, so you probably can mention like tools like Kafka. I don't know. People sometimes mention Flink, but I have to say that one of the best solutions in the market is RatingWave. It's pretty good at real-time data ingestion. If you have streaming data, you can directly use RatingWave to sync to Iceberg. The challenge here is that it's not about which tool you use, right? And it's more about whether it's any pattern, because a lot of people will say that like Iceberg is not very good for fresh data, high volume data or high velocity data, right? But the thing here is that in either Kafka or in RatingWave, we actually allow people to do the compaction. I mean, not compaction, the batch sync. So basically, you can batch, let's say, 5-minute data or probably 10 minutes data in your engine. Let's say in Kafka, right? Well, you know that in Kafka, you can control the flush, right? Well, you can control the commit. And in RatingWave, you can do the same thing. And in this way, you can ensure that you probably don't really want to you will not have so many small files. So agree that Iceberg is, as the slogan says, it's for slow moving data. Yeah, but I have to say that the modern tools like Kafka, like RatingWave, they actually can help you to control the commit frequency, so that you will get rid of this kind of problem. Well, there are so many questions about the compaction.
Yeah. So I think just to add to the ingestion part, that's something that we solved in Absolver, because we had the same problem. We had customers who were writing 5 million events per second into Iceberg.
Wow, what's that kind of like IoT?
No, it's ad tech. So collecting a bunch of like statistics from mobile phones. And writing them into the lake, because there was no way in hell they're going to write that into a warehouse. So you had to write it into the lake. And initially we were managing it on Hive, but then we transitioned that into Iceberg. But you're right, writing into Iceberg is tough, because every time you write some data, you have to commit a snapshot, right? And there's a whole bunch of metadata you have to create, and there's extra work you got to do. For append only, it's fairly easy to do, right? You can actually make it work, and we did that. For merge use cases where you have a CDC that's pushing, I don't know, like 1,000 events a second. We have one customer that does, I want to say like around 900 events or rows per second from a SQL Server database. So when you're updating and deleting those a lot, you're creating a lot of delete files, right? Mm-hmm. And then to write those delete files, you have to kind of scan the data and find where the rows to be deleted are, and then create a delete file. So we opted for the equality delete support inside of Iceberg, and that works fairly well, but it's not really well supported in query engines, right? So you kind of have this dilemma. I can write real time into Iceberg and manage these deletes, but most query engines can't query it. So like Trino and Presto can do it. Snowflake doesn't do it yet. Spark can do it. I don't know about Dremio. And then to switch to positional deletes, which all the query engines read, then it's a lot slower. you can't update your tables as quickly. So it's a bit of a dilemma, and I think the community is kind of working on this. They're kind of consolidating on these delete vectors and trying to figure out how do we actually support these CDC use cases and more near real-time need for updating and deleting rows. But we've done that in Absolvo. We have few customers who do that today, but it wasn't easy.
Yeah, well, I mean, we only have 3 minutes left, but there are so many questions in the channel, right? And we also have actually have a couple of slides talking about really, okay, I mean, so many slides.
We'll try to answer some of the questions offline too. So
let's talk about, okay, just use the 2 minutes, okay, to discuss query engine, right? And so there are questions like, okay, in our company, we use views in Trino on Iceberg tables. We are struggling with finding a solution to query the Trino views from Spark. Do you know there's any solution to query a view? And there are also questions about, okay, what's the performance comparison between among compaction on Spark, Trino, Flink? Yeah, for the compaction, typically I would say probably Spark is a standard, right? But well, Alex, can you give a quick answer? Any question you want to
answer? On the view question, there is some work trying to figure out how to make views more interoperable. I'm not going to quite go too deep into it now, but I do have a blog on Medium that calls about 10 things to look forward to in Iceberg that actually covers this whole view thing and a couple of the different options they're discussing as far as how to make views more interoperable. But right now, it's tough just because right now views are saved as SQL and SQL isn't identical for every engine. So it's hard for those views to be perfectly interoperable.
Yeah, I mean, just to add to that, I think Iceberg is actually helping address that. So they're right, because Spark views and Presto view, Trino views are different, just the way they're encoded is different. But with Iceberg views, basically it's going to give you the option to say, I want an Iceberg view to maintain a representation of both Spark and Trino, right? So if you're coming from a Spark engine, you can say, give me the Spark view representation of this view SQL, and then I can execute. If I'm coming from a Trino engine, I say I want the Trino engine type of view, and it'll return it back to me, right? So this way you're not managing multiple views, you're managing one view called the Iceberg view that has multiple representations of it that's applicable to that's compatible with different engines. But it's a known issue, and I think the Iceberg spec for views is going to address this.
Cool. And yeah, we have already spent 1 hour on this topic. But for unfortunately, yeah, we are time's up. But for like, there are so many questions in the channel. And how about this? We probably can answer some of the questions offline, and potentially we can also host a second webinar on this topic. Sounds good to you guys? Okay. All right.
Sounds good to me.
Yeah. All right. Thank you so much for attending the webinar, and I will share a channel. I will share our space to discuss all these questions offline. Okay, and hopefully we can have a second webinar on this topic. That's why I do still have a lot of questions on this. Well, like S3 tables, right? And let's say the query engines. Okay, graph computation, vector search, right? Well, how to do that in vector on Iceberg. I definitely want to have an answer. Okay. All right. Thank you so much, and thanks for Alex and Roy for joining the webinar. And yeah, see you next time. Okay.
All right.
Have a good one. Thank you.
Appreciate
Hey,
it.
add us both on LinkedIn, me and Roy.
Yes, definitely.
Yeah, sure. Yeah. Let's discuss on LinkedIn. All right. Thank you.